Hi everyone, we are on to special right triangles. This is chapter 8, worksheet number 5. So here we go. There are two types of special right triangles we're going to be talking about. The first is the 45, 45, 90 triangle. And I'm well aware that this is a square that we're looking at, not a triangle, but the logic of it comes from it. So if we look at this square, and we cut it down the middle, based on the properties of a square, we know that we have 45 degrees here and 45 degrees here, so this is a 45, 45, 90 triangle. If I make the sides 1, we know that those sides will be congruent, so each of those is 1. If we then perform the Pythagorean theorem to solve for the hypotenuse for the right triangle, we get 1 squared plus 1 squared equals c, 2 equals c. Now, this pattern will always happen in a 45, 45, 90, because think about it. Whatever's here will always repeat. If this is a 2, this is 2, 3, 3, etc. So we're going to come up with these rules. If we're going from the leg to the hypotenuse, you're going to multiply by radical 2, because 1 times radical 2 is radical 2. If you are going the opposite way, if you're going from the hypotenuse to the leg, you're going to divide by radical 2, because that, again, will always happen. And the reason being, all 45, 45, 90 triangles are similar to one another. So that proportion will always happen. Let's practice with that. So I have the leg, I'm going to the hypotenuse. So I applied the multiply by radical 2 rule, and I get 10 radical 2. It's that easy. Again, 6, I'm going from the leg to the hypotenuse, so it's 6 radical 2. Leg to the hypotenuse, so it's 2 radical 2. Now I'm going the opposite way. I'm going from the hypotenuse to the leg. So I have to divide by radical 2. Well, 8 radical 2 divided by radical 2, the radical 2's just cancel, so I'm left with 8. And if that side's 8, the other side has to be 8 because they're congruent. Same thing's going to happen here. I have 3 radical 2. I'm going to divide it by radical 2 because I'm going from the hypotenuse to the leg. And I get 3. If that side's 3, the other side's 3. Okay, let's do one that's a little bit harder because it doesn't have a radical 2. So this is going to be radical 8 divided by radical 2. Let's do a little bit of side work. I can't have that radical 2 on the bottom, so I need to multiply both top and bottom by radical 2. Or you can apply, if you know your rules, and you can divide this, it's radical 4, but either way we'll get there. So I end up with radical 16 over 2. 4 divided by 2 is 2. So that is how you go from hypotenuse to leg. You're dividing radical 2. Sometimes you have to do a little bit more work to get that. So let's do it here. 5 radical 6 divided by 2. Again, I'm going to rationalize, so I'm multiplying top and bottom by radical 2 to get that out of there. So I get 5 radical 12 over 2. Radical 12 can be simplified to 4 radical 3. Excuse me, to 2 radical 3. 12 is 4 times 3. The square root of 4 is 2. So 5 times 2 is 10. So I have 10 radical 3 over 2. This 10 and 2 simplified to a 5. So really, you just have to do 6 divided by 2 is 3. I'm just showing you the work. So as you can see, radical 6 divided by radical 2 is just radical 3. Okay, now an 8 without a radical. So this is where you absolutely do have to rationalize. But there's going to be a pattern that you're going to notice, and it always happens that way. So again, I'm going from hypotenuse to leg, so I'm dividing by radical 2. I have to rationalize. So I'm rationalized by multiplying top and bottom by radical 2. I get 8 radical 2 over 2. Now, 8 and 2 reduce to 4, so I get 4 radical 2. Notice, when I didn't have the radical, and I divided by radical 2, I got half of this number, radical 2. That will always happen. So if this were a 10, this would be 5 radical 2. If this were an 18, this would be 9 radical 2. If this were a 20, this would be 10 radical 2. That pattern always happens. So for instance, if this is a 6, I'm going to get 3 radical 2. I'm showing you the work to the left, but you're always going to get that 3 radical 2. And you can absolutely just jump to that because it's a pattern that you 100% can know without showing the work for. All right, let's talk about a 30, 60, 90 triangle. In a 30, 60, 90 triangle, which I've cut here. So I had an equilateral triangle. I then bisected one of the angles, so it's a 30 and a 30. So if I have an equilateral triangle and I make this piece here 1, well, that means that this piece would also be 1. So this whole leg is 2, which means both of those legs are 2. If I then perform the Pythagorean theorem to solve for the missing leg, I get radical 3. And here are where the rules come from for the 30, 60, 90 triangle. So when you go from the short leg to the hypotenuse, well, 1 times 2 is 2. You're multiplying by 2. If you go from the hypotenuse to the short leg, you're going to divide by 2. From there, we're going short leg to long leg. So to go short leg to long leg, I went from 1 to radical 3. So I multiplied by radical 3. Then to go backwards, I divide by radical 3. What you need to notice with the 30, 60, 90 triangle is that it's all about the short leg. Notice how in all of these it's talking about the short leg. So no matter what, you need to get to the short leg. You cannot go from long leg to hypotenuse without first figuring out what the short leg is. So let's practice with that. I have the short leg and the long leg I'm looking for, I have the short leg and the hypotenuse, I'm looking for the long leg. So I multiply by root 3, I use those rules, and I get 4 root 3. Same thing, I'm going from short leg to long leg, so I need to multiply by radical 3. Short leg to long leg, multiply by radical 3. All right, now let's change it up a little bit. I'm going from short leg to both the hypotenuse and the long leg. So let's go to the long leg first, 7 radical 3. And to go to the hypotenuse, I multiply by 2, so that's 14. Okay, now I'm given the hypotenuse. Remember, you cannot go from the hypotenuse to the long leg. So you have to first go to the short leg. So to go from the hypotenuse to the short leg, I divide by 2. And then to go from the short leg to the long leg, I multiply by radical 3. I'm just applying those rules. You're going to want those charts out next to you probably while you're practicing. Okay, to go from long leg to short leg, I divide by radical 3, and I get 8. And then to go from short leg to hypotenuse, I multiply by 2 and get 16. Okay, now we have to go from long leg to short leg, so I have to divide by radical 3. So this is very similar to what we did in the 45, 45, 90, but now it's a 3, not a 2. So when you rationalize this, you're going to end up with 3 radical 3. And I showed the work there on the right. It's that same pattern. 9 divided by radical 3 is just 9 divided by 3, which is 3, with the radical 3 on it. That pattern will always happen. So again, if this is a 21, this would be 7 radical 3. If this was an 18, this would be 6 radical 3. If this were a 30, this would be 10 radical 3. It's that same pattern. But again, I showed the work over here so you can see where it came from. Now to go from short leg to hypotenuse, I multiply by 2. 2 3 radical 3s is 6 radical 3. It's that simple. All right, so 21. So again, I'm dividing by radical 3. I'm showing the work to the right, but it's that same pattern of 7 radical 3. I multiply that by 2. I get 14 radical 3. On and on we go. 5 radical 6 divided by radical 3. Again, I can just divide the radicals. I'm going to end up with 5 radical 2. And then to go from the short leg to the hypotenuse, I multiply by 2, and I get 10 radical 2. So again, radical 6 divided by radical 3 is radical 2. I'm just showing the long way around. And then multiply by 2. That's it. It's a pattern. You got to get used to the patterns. Have a great day. I will see you in class.